Hello and welcome to PowerBench. Today I'm going to be reviewing this iMuto Taurus X2 power bank. This one I bought from Amazon. It was on a lightning deal and it cost me just under £13. I have to admit this is not a genuine unboxing. I have had this open and I have used it a couple of times. This is the power bank that encouraged me to start making these videos. So I will start with the opening. Even if it's not going to be quite as fresh out of the box as it ought to be. This one is 10,000 mAh, it has a pair of USB ports and a little display which shows the remaining power capacity, and if you look at the specs on the back, 10,000 mAh or 37 watt hours. It can output 2.1 amps per port. It weighs 8.55 ounces and size in inches 3.8 by 2.55 by 1.18 inches. So it is quite small. Let's open her up. Nice box. So inside there's a little carrying bag. Seems okay. It's got quite a nice feel to it, slightly rubbery, drawstrings, might even be slightly waterproof, so that's nice. We've got a thank you for purchasing card, a manual, we don't need that. And then in here is the power bank. Comes in one of those nice soft feeling plastic bags, which is always pleasant. So you can see we have, let me just adjust the colour balance slightly, that's better. So we've got a micro USB input for charging, a pair of standard USB-A, a power button on the side, nothing on the bottom or the other side. A little company logo, it's nice embossed. Again, let's turn on auto brightness for now, so you can see that's embossed, which is quite nice, looks right. And then we've got some regulatory information on the back, including the Conformité European mark, which is the genuine one with the extra space in it. Whether or not it's a genuine mark I don't know, but at least they've used the right mark. And you can see here output to USB 5 volt 2.1 amp max. So, check what else we've got in the box. Bearing in mind I sort of already know this, there's a cable, and that's it. Now the cable, let's get rid of the box. The cable also has the branding on the micro USB end, which is quite nice, and on the regular USB end, so there's no real danger of losing this cable. It's decently thick, if I can get the ruler out. It's about 4mm out exterior diameter. It feels quite nice, it's reasonably flexible. Whether or not this will prove to be a good cable, we'll find out in a bit. So first up, capacity test. Sorry, not capacity test, peak load test. We've got our USB load here, power bank here. If we press the power button, what do we have? So this has been turned off. It was fully charged. It's been turned off for probably 3 or 4 weeks at this point. So it retains about 99% of its capacity, which, well, 99% of its claimed capacity. One of the things I will do during the capacity test video is keep an eye on what the discharge rate is versus the percentage remaining on the display, so we can see whether 99% is a real figure or whether that's just something that it reports for ages. So we'll plug in. I've got these the wrong way. This is going to be a constant problem. So we're in. Turn the dials down. So it's currently outputting a steady 5.08 volts, which is fine. Sometimes these devices boost. Oh, hello. Oh, because it's not drawing any power, it's turned itself off. Fine. Sometimes these boost the voltage slightly when you actually start drawing some current to overcome any cable loss, but we'll see whether this is true. So if I press the power button again, this has woken up. Good. Let's use some power. So half an amp, standard USB 2 power draw, still 5.08 amps, which is fine. Let's go to an amp. Turn that up slightly. There we go, 5.02 volts. Okay, still within spec. Let's go higher. So 1.5 amps. Still 5 volts, that's okay. 2 amps. So we're starting to drop a little bit. There we go. Still at 5 volts. Turn this up to 2.1 amps. There we go. So the voltage has dropped ever so slightly to 4.96 volts, which is it's fluctuating a little bit, but it's close enough. That's within spec. Normally you don't want it to be below 5 volts, but that's okay. So we're down to 98% apparently, which is fine. So that's okay. It seems to draw its rated power. If we turn it up a little bit further, what point does it stop? So 2.4 amps, slightly below 5 volts, but again, that's pretty good. And again, we're outside of the claimed spec here. Oh, there we go. So that's dropped off. So it will deliver a bit over 2.1 amps. But it does seem to be, I think at 2.4, some devices will pull 2.4. It looks like this will deliver it, but you're getting pretty close to the limit there, that's okay. It claims 2.1, it delivers 2.1. So far so good. Let's test the cable that comes with it. Now it's quite, probably ought to check the length first. I probably ought to check the size of the thing. So while we're doing that, sorry for being a bit disorganised, the cable length is pretty much 2 feet long. It's about 60 centimetres. So it's quite a long cable for a power bank. The actual device itself is just under 10 centimetres, or just under 6.5 centimetres. Like this, you can't see any of this, can you? 6.5 wide, and just under 10 deep, and about 3 centimetres deep. It feels quite heavy in the hand, it's quite dense. It's got a good feel to it. Let's just check how much it weighs for the sake of completeness. Turn on the little scales. They're zeroed. 242.3 grams. So that makes it just over half a pound. Slightly over 8 ounces, which, what did the box say? 8.55, yeah. So that's good. Always nice to see that something meets the required spec. So, back to this cable. So, standard micro USB cable. We'll plug it into the back of the load. It's woken up. So at 0 tiny amount of amps, it's outputting 5.1 volts. Interesting, do those two sockets deliver different amount of power? Different voltage, sorry. So if we turn up to half an amp. So let's make sure we've got a nice clear view of the voltage. So use the standard little porta-power meter because this is quite nice. So this way we guarantee we've got the correct voltage. So they're both reading 5.12 volts, that's good. With a tiny amount of load, so let's turn that up to half an amp. Yeah, so it is dropping the voltage slightly, that's fine. So half an amp, we've got 0.09 volts drop. So 1 amp. Almost 0.2 volts, which is not great, but it's not terrible. It's a reasonable length cable. It's not as bad as the little pink one, which I reviewed before. And if we go up to the 2.1 amps on spec, so again, this is the stated maximum output of the power bank. So we're seeing every 0.495 to 0.35 of a volt at 2.1 amps, which isn't bad. It's not brilliant. Just for the sake of consistency, 4.59. If we switch to using a good cable, this is one of the new high power anchor ones I've got. .7 volts at 2.1 amps. So that's 0.24 volts dropped. So better, but the cable that comes with it seems okay. Perfectly reasonable to use with your device with this power bank. So far I'm impressed. Turning this back on, it's now showing 96% capacity, and we just wasted a load of power as heat, so this seems like a good opportunity to charge it back up. I will use the built-in cable because it's not too bad, and again we'll use the little porta-power meter because it shows up nicely on screen and it's reasonably accurate. Let's just reset the count. There we go. So you can see it flashes while it's charging. And it's drawing 0.84 of an amp while it charges, that's pretty good. Right, I will leave this until it's charged and then restart the video. Time for the capacity test. Apologies if you see any weird continuity errors here. This is a re-recording of the previous video, and the reason for that is that I'm changing the meter from this one because the power loss through these cables at 2 amps is significant enough to skew the result. I've done some testing, and this meter, possibly because it has no cable, seems to be the most accurate I've got for measuring the power out of the power bank. I've also changed the load from this one, which is great for testing cables, but as I've discovered, if you turn the current up past about 2 amps, it starts turning the load on and off at very high frequency, which doesn't affect the readings at all, but it does make the data on the oscilloscope look because the oscilloscope's fast enough to capture it, so it makes the lines go very wide, which is not ideal. I'd rather have something precise. This load doesn't suffer from that problem, so it should make for better pictures, hopefully. So, on with the test. It's fully charged, as you can see. We plug in the meter. Now, the downside of this meter is you can't see it and the display, so I'm going to use the figures for the display that I saw previously. They're close enough, but 5.1 volts, no amps. So let's make sure this load is turned down, which it is. Always get these the wrong way around. That's visible. Yep. So, as before, the meter is plugged straight into the power bank, so this will be capturing all of the power that's transferred. Let's turn that back on. You'll notice some figures on here. These are flashing. They will go away. They'll be reset to 0 once power transfer starts in any meaningful capacity through the shunt resistor to collect current figures on the oscilloscope. You can see here 5 volts for the blue line, currently 5.16, 5.2, and the yellow line is current, no amps flowing at the moment. This load is also reading 5.10, 5.11 volts. These are in agreement. The oscilloscope is off ever so slightly. It's designed for high frequency measurements, not super accurate measurements, because I've got these probes in 1x mode, and the level of precision you get, it depends on how zoomed in the figures are, but it's close enough to spot a trend. So this has turned itself off again, which is fine. I will turn it back on and then we'll crank up the power. So we're going to go for 2.1 amps as before, which is the rated capacity of the power bank, and then I will record the entire process and speed it up so you don't have to sit through it all. Here we go. Power that on. Turn up the load. You can see it's a slightly garish green colour, this one. Slightly too far. .10 amps, 2.11, close enough. There is a slight voltage drop across this shunt and through this cable, so explaining the discrepancy between, we're seeing 4.96 volts on the little meter and 4.74. If we fire up the multimeter, you can see that. Let's tilt that up slightly. .76, 4.74. The resolution of the volts on this isn't amazing. It seems to step in 0.08 volt increments. I think because the analog to digital converter on this is spread across the whole range of the voltage, but that's a separate issue. And then you can see if we do the same across here, 4.8, so there's a very small amount of voltage drop through there, nothing to worry about. But as we're taking the readings directly off this meter, those are the ones that count for the capacity test, so that's fine. You can see on the multimeter, oscilloscope, sorry, we've got a nice steady 4.96 volts we're reading on the blue line, and the current figures we're seeing is fluctuating slightly, but around 2.1 amps, so that's fine. Average is currently 2.11 amps, so again, pretty much spot on. Right, I will let this run until the USB supply goes off. So it looks like the power's died, and it's outputting 0 volts, which is what we'd expect. So let's unplug this and see what the final readings are. I don't know if there'll be enough juice for it to light this up. No, fine. So let's use a USB cable. So it's reporting 6,021 milliampere hours, which is ever so slightly less than the first test, or 29 watt hours, nearly 30 watt hours. I will calculate the figures that returns, but you can see them here on this meter. This meter, I'm not entirely convinced on the accuracy of its figures, but it's reporting 6.12 ampere hours and 29.23 watt hours. Now the watt hour figure will be slightly lower because of the voltage drop due to the cables and the shunt resistor, but the ampere hour figure isn't actually that far off, so maybe that one's not as bad as I thought. But anyway, this is accurate. 6,000 milliampere hours it is. So a couple of things before I finish up the video. The first is that I haven't looked at the capacity of both USB ports in use at the same time, so we'll do that quickly. And the second thing is I've been through the video and I've looked at the output of the LCD display and plotted that versus the amount of power delivered. And I'll overlaid the graph on this video. You can see that it's relatively straight. The figures that are displayed on the little screen, I've just semi-recharged this, I've been playing with it, are actually pretty good. They're reasonably realistic expectation of the amount of power remaining, with the exception of 10% to 0%, which seem to last forever, which is no bad thing. So when you get to 10%, you've actually, it seems, got a bit more power left than initially appears. So just to test both USB ports, I'm going to use this meter. So it shows up quite nicely. I only need to extend one port so everything will fit. So just to prove how this works, I've got my 2 amp resistive load, which just to plug that in and show you, let's turn this on. So it's in 1 amp mode at the moment. There we go, 0.997. If I switch it into 2 amp mode, 1.9 amps, so it's not perfect, but it's reasonably close. So I'm actually going to plug that in. Ow, that's hot. Plug that in there, and plug that in there, and then I can attach the previous load. Make sure everything's turned down low. So I'll put that into 2 amp mode. 1.9 amps, bit of a slightly precarious setup this, and then turn this up. I'm dialing the fine adjustment one, my bad. So 0.7 an amp. It's interesting, it's dropped the negotiation to 1.5 amps according to this display. Turn it up, 0.95, so just under an amp. So I read the spec, yeah, it's dropped to 3 volts at 1 amp, so that's the definite limit. Yeah, and if you drop off a little bit more, so it drops off quite considerably voltage wise at about 2.5 amps again. So that's okay. I read the spec on the box, which I have here. there we go. So I read the spec on the box to say that there's 2 ports, 2.1 amp maximum, rather than, so I think it's 2.1 amps maximum rather than both ports will do 2.1 amps. It'll actually do 2.5 amps reasonably reliably, it seems. So that's fine. Once again, apologies for the chopping and changing slightly. This is the final follow-up for this video. This is recharging now. You can see it tells you the capacity as it charges up. And as the discharge happened, looking back through the figures on the video, this did cut off nice and cleanly, so it was running along at 5 volts, and as soon as it reached its finished capacity, it was a straight cut off, no dropping down to 4 and then 3 and then 2 volts, which does not make for a happy experience for devices that are plugged in. So on that, it was good. It performed reasonably well. The actual capacity of this thing under test, I'm going to report these in watt hours rather than ampere hours because it accounts for the conversion between the 3.7 volt cells inside these and the 5 volts that they output. So the capacity, according to the box, to save me doing the calculation, is 10,000 milliampere hours or 37 watt hours. So that would be 10 amp hours times by 3.7 volts of the internal cells is 37 watt hours, which is correct. That's what you'd expect. I just realised you can't see this. There we go. Let's reset the exposure. So 37 watt hours. The actual measurement on the discharge test was 29.828 watt hours, or 6,021 milliampere hours at 4.96 volts. So 29.82 watt hours divided by 37 watt hours gives us 80.6% efficiency, which is, it's okay. Anything over 80 is reasonable for one of these. The conversion between 3.7 volts of the cells, the little boost converter up to 5 volts for USB, isn't a perfectly efficient process, so anything over 80% is okay. 80.6 is acceptable. So on the whole, it's an okay power bank. I believe it has the claimed capacity of cells inside it. It works reliably. It delivers the current that it claims it can, and it's got a nice feel to it. It's got a solid kind of. It feels solid in the hand. It's a good weight. So on the whole, recommended. Thank you for watching this video. Please subscribe to the channel if you'd like to see more of these. I've got a lot more power banks to test. There will be regular updates to this. There's also a website at powerben.ch or powerbench. There'll be a write-up on there for all of the power banks I test, which will include the same information as on the videos. But if you prefer not to watch the videos, then that's fine. But if you want to continue to see the making of, please subscribe to this channel. There's also a Patreon account I've got set up, which you can support this channel. If you can chuck in a couple of dollars a month, that'd be great. I buy all of these power banks out of my own money, so I don't accept review samples from other companies to ensure that the quality of the reviews is unbiased. So anything you can do to help me buy more equipment for testing, it'd be very much appreciated. Thank you for watching, and have a nice day.